Hi, this is Dave out in Western Pennsylvania. I work with batteries, and recently I've been working with aluminum alkaline batteries, substituting aluminum for zinc. And excuse me, the cathode is aluminum from pie pans. I don't use the aluminum foil, it's too thin. And what I have in this situation is a D-type preparation. Now, I use things laying around with some of my non-science students, and maybe this will interest you. On eBay you can find hair curlers, and the type, there's all different types. Look for the ones with a plastic cylinder with Velcro wrapped around the outside. And what I do is I remove the Velcro from the outer side and I put it on the inside. And I'll take a tea bag or some porous paper toweling, and I will do a line of the anode preparation, and that is ground up in a coffee grinder. What I use is activated carbon, manganese 4 oxide, manganese dioxide. I grind that up 50-50. I add to that, for 95 parts of that, I put in 5 parts of sodium polyacrylate for gelling. And then I add 10% sodium hydroxide. Now, that anode is then placed inside the hair curler, which in turn is surrounded by, which hopefully you can see it, the aluminum from the pie pan. And I use a D battery as a template to form that aluminum. I cut little strips on the bottom and fold it at the base. And I have graphite in there as the current collector. Freshly prepared, in about 2 minutes, a period of induction, you'll hit 1.60 volts initially, and that's open voltage. Open circuit is well above 200 milliamps. That's a short circuit, about over 200 milliamps. Now that's freshly prepared. Now what I do, I hook it up to, hopefully you can see that, an alternative joule thief. And I have uploaded a YouTube video on this, and that alternative joule thief is basically the guts of a garden solar cell. I unscrew the 2 screws, pop out the nickel cad rechargeable, and hook up alligator clips. And this little white LED, normally white LED requires 3 volts. This little one in the garden cell is paired with a nickel cad rechargeable, which is only 1.2 volts and a modest 200 milliamp hours, but enough to light this at night. So what I do is I attach the alligator clips to my battery, and I know from experience that I can keep this lit down to as little as 0.52 volts. Now of course I'm going to be hooking this up to vernier circuit boards with sensors to monitor voltage, current, and power output. And I need to make about 10 of these batteries to do a little bit of statistics to see the degree of variation I get, because they're homemade. But it's worthy of study. Now, what I'm going to be doing is adding varying amounts of nickel oxyhydroxide, which is known to boost zinc alkaline battery voltages by as much as 15-20%. On YouTube you'll find a video by Murray Smith who will explain to you how to make from nickel 2 chloride and bleach and sodium hydroxide nickel oxyhydroxide, a black powder. Very easy to prepare, and in fact I have some in the bottle right here. This is what it'll look like, black powder. And I'm quite interested in blending in varying amounts of nickel oxyhydroxide with the manganese dioxide. So I'll keep you posted on this. And this is probably even better than the CD approach. I've prepared some of these aluminum alkaline batteries in empty CD cases, but I actually think it's probably a lot better, and you have more anode material, to go with this pseudo D cell for study. So I'll keep you posted on what's going on, and maybe you want to try your hand at it. And thanks for watching. Bye for now.